here's the section on special right triangles. So this is the section we mentioned earlier where we were going to be using a lot of the roots and doing some work with those and having to simplify them. So this is the section where you might have to review some of those skills. Just to begin, if you look at the very top of the page, it says the ratio of the lengths of any two sides of a right triangle is a function of either acute angle. So essentially what they're trying to say is that the sides of a right triangle, these two in particular, have a relationship with each other. There's a pattern that is happening. That's essentially what that first sentence is telling you, okay? So maybe you might want to make some note on there that really this is just telling you there's a pattern. Okay, so there is going to be a pattern happening here. The other thing you definitely want to make sure that you keep track of is the fact that these are special right triangles. This doesn't work for every single right triangle. These two particular triangles on your page are very special. So this can be proved, the fact that there's this pattern, using similarity theorems and is the basis for the 6 trigonometric functions. We're going to be learning those throughout the chapter and in another chapter. The fixed side lengths of a 45, 45, 90 and a 30, 60, 90, easily found by applying the Pythagorean theorem, provide benchmark values for the trigonometric functions sine, cosine, and tangent. We're going to learn more about sine, cosine, and tangent in some of the following lessons, but for now we're just going to practice using our special right triangles. And so here are the special relationships. So if this is a right triangle, then we have a 90-degree angle here. And since the other two are listed as 45, 45, then that's telling me that this is 45 degrees and that this one's 45 degrees. So that means that these two angles are congruent to each other and they're equal. And if you think back to an isosceles triangle, you'll remember when we dealt with isosceles triangles, we said that if the two base angles were equal, their opposite sides were also equal. So if you tip that over, tip it this way, and make sure that it's a right angle in there, we actually have an isosceles triangle in our 45, 45. So these two sides are equal, and we're going to call them n. They're both going to be called n because they're equal in length. And the hypotenuse in this triangle is always the side length n times the square root of 2. So if the side length was 7, the hypotenuse would be 7 square roots of 2 in length. You could find that out decimally if you really want to know what 7 square roots of 2 was equivalent to. But it's more accurate to say 7 square roots of 2. I know we've talked about that in the past. It's more accurate to just say square root of something than it is to actually put the square root into your calculator and then have it give you a long, super long decimal that you then have to round. Every time you round, you're taking away some of the specific of that number. You're taking away some of its value. So we always want to leave it in root form when we can. Okay, so 45, 45, 90, the two sides are n, and the third side is n square roots of 2. These values, n, or these labels, n, and n square roots of 2, and a 45, 45, 90, you have to commit those to memory. You're going to need to know how to label the sides, n, and n square roots of 2, for that 45, 45, 90. It's very important that you know that. We're going to use these constantly through the rest of geometry. We're going to definitely use them again in Algebra 2 when we deal with the unit circle. So this stuff, this trigonometric stuff we're learning is not going to go away. So I really need you to make sure you commit to memorizing these. The next triangle, 30, 60, 90. Here's my 90. And if you are confused about which angle is the 30 degree and which angle is the 60 degree, think about it like this. This angle at the top is a teeny, tiny, tiny angle. And so it must be 30 degrees. And you also know that it's the 30 degree angle because it is across from the short side. Okay? So that's the 30 degree angle. And then this is the 60 degree angle. And so since those angles are not the same, the side lengths opposite them are also not the same. So they have pretty different measurements. They're not as easy as the 45, 45, 90. But I will try to tell you something that will help you to remember how to label it. So this is how I remember it. 30 degrees is the smallest angle, and so that's where I start. I put n across from my 30, okay? So across from the 30-degree angle is going to be n. That's where you start. Okay? The smallest side is n. The hypotenuse is always twice that, so 2 times n. And then what we call the long leg is n square roots of 3. Again, those values, n, 2n, and n square roots of 3, you're going to need to commit to memory. And it's important that you're able to put them in the proper place. It's super, super important. Okay? So, I'm going to scroll the screen up, and we're going to work on just applying this to some triangles in these 4 examples in the boxes, okay? So let's start with this first one. Find the length of the hypotenuse of a 45, 45, 90 triangle with legs of length 5 square roots of 6. So the first thing you do is draw yourself a right triangle, and of course that's your 90. So it's a 45, 45. So I always just put the 45s in the corners. So 45, 45, 90. And then you want to label your sides. So I want to call this n, and n square roots of 2. Okay, those are important. You just plop them in there. That's always how you start the problem. Draw the triangle, whatever one you have, and label the sides. Very important that that's what you start with. Then it says that the triangle has leg lengths of 5 square roots of 6. So then I'm going to say to myself, well, if this leg length and this leg length is 5 square roots of 6, then I know that n equals 5 square roots of 6. Both places, n equals 5 square roots of 6. That was given to us. And so the question is, how long is the hypotenuse? So that's where we need to figure out how long the hypotenuse. That's my variable. So equals x. And then it just becomes a point of trying to solve this. X equals n square roots of 2. So I can't do this right now because there's 2 variables in the equation. I can't figure out what x is. I don't know the length of the hypotenuse. But I do know that n is 5 square roots of 6. And since I know the value, I can plug it right into the equation. So x equals n, which is 5 square roots of 6, times the square root of 2, and then I just need to simplify. And so you'll remember back to when we talked about this in the last lesson. We're going to take these 2 and we're going to multiply them together and put them under one root. So we get 5 square roots of 12. X equals 5 square roots of 12. Okay? We're going to leave it just like that. We can reduce the square root of 12 a little bit, but I'm not concerned about that right now. I just want you to be able to label the sides of the triangle and find that missing 1. Okay? Let's look at the second one. The longer leg of a 30, 60, 90 triangle has length 18. Find the lengths of the shorter leg and the hypotenuse. Okay, so let's label what we know. We have 30, 60, 90. Across from my 30 is n. My hypotenuse is 2n. And across from my 60 is n square roots of 3. And now in a different color, I'm going to label the other information. The long leg has a length of 18. So this equals 18. N square roots of 3 is equal to 18. Find the lengths of the shorter leg and the hypotenuse. So I often will say to students, can you solve this with just a variable? No. Is this an equation? No. Is this an equation? Yes, it is. So that's the one that we're going to try to solve. 18 equals n square roots of 3. So this is just like back on the first page, the pre-teaching of the root lesson. If you need to go back there and look at it, remember we're just trying to isolate the n, so we're going to divide both sides by the square root of 3. And we get n equals 18 over the square root of 3. Can we have a square root in the denominator? The answer is no. So we need to eliminate it. Remember we said on that very first lesson in the chapter that to eliminate the root in the denominator, you multiply by the square root. So we multiply by that square root of 3. If you multiply across the bottom, square root of 3 times the square root of 3 is 3. And then if you multiply across the top, you get 18 times the square root of 3. And then you'll remember that stupid story I told you about shooting soldiers but not the queen. We don't want to hurt the queen, so we can't do anything with the 3 under the radical. But 18 and 3 are all divisible, or both divisible by 3. So we're going to shoot some soldiers. 3 goes into 3 once. 3 goes into 18 6 times. 6 times 3 is 18. So n equals 6 square roots of 3. So this side length, the short leg, is n square roots of 3. Sorry, is 6 square roots of 3. Let me fix that for you. 6 square roots of 3. And the other thing we had to find, we found the short leg. Now we have to find the hypotenuse. The hypotenuse is 2 times that. So the hypotenuse is 2 times 6 square roots of 3, or 12 square roots of 3. So short leg is 6 square roots of 3, hypotenuse is 12 square roots of 3. Okay? So these are going to be a little bit challenging, and it's okay. You just have to sort of take your time and think about what's happening. Okay? So let's look at the third one. Find the length of a leg of a 45, 45, 90 triangle with a hypotenuse of 22. So let's go ahead and draw our triangle. We have a 45, 45, 90. And we're going to label our sides n, n, and n square roots of 2. And they're telling us the hypotenuse is 22. So I'm going to go ahead and put that in there. The hypotenuse equals 22. And so let's use the same strategy we used last time. Can I solve this side? The answer is no, because there's no equal sign. Can I solve this side? Again, the answer is no, because there's no equal sign. So I'm going to have to solve this side. So this is the side I want to solve. N square roots of 2 is equal to 22. That's the only side that is an equation. So what you're doing each time is you're labeling them, all the sides, and then you're figuring out which one is an equation. I need to solve that one. So in the first example, the n square roots of 2 is equal to x. That was our equation. And we plugged in a value for n right here to then solve. In the second example, we labeled all of our sides n, 2n, and n square roots of 3, and this was the only one that had an equal sign, that was an equation, and so that's what we tried to solve. And we're going to do the same thing down here in question number 3. We're going to just look at all 3 of the examples and which one is an equation. So the hypotenuse is our equation. We're going to divide by the square root of 2. N equals 22 over the square root of 2. And I hope right now you're saying, oh my gosh, we cannot have a root in the denominator. And so we have to eliminate the root. We have to rationalize the denominator. Multiply by the square root of 2. Okay, we're going to multiply across the bottom. That's going to give me 2. Multiply across the top, and I get 22 square roots of 2. Now there's only one of those that I cannot simplify, and that's the queen inside the castle, but I can shoot some soldiers. So 2 goes into 2 once. 2 goes into 22 11 times. So I get 11 square roots of 2. Okay, protecting the queen in the castle. 11 square roots of 2 is the length of n, or the length of the leg of a 45, 45, 90, because we just solved for n equals 11 square roots of 2. So this side is 11 square roots of 2, and this side is 11 square roots of 2. Okay? When we look at example 4, a garden shaped like a rhombus has a perimeter of 100 feet and a 60-degree angle. Find the perpendicular height between the 2 bases. So a garden shaped like a rhombus, so we have to know what a rhombus looks like, has a perimeter of 100 feet and a 60-degree angle. So it says to find the perpendicular height between the 2 bases. Okay? So a rhombus looks sort of like a parallelogram, except that all the sides are equal. Okay? So it kind of forms a square. and we know that the perimeter equals 100 feet. So knowing that a rhombus has all four sides equal, I have to take that 100 and I have to divide it by four sides, and that gives me 25 per side. Okay? So I know that all the sides are 25. So 25, 25, 25, and 25. And then I know that there's 60-degree angles. So all the angles, or these two angles I should say, this one is 60 degrees. So it says to find the perpendicular height between the two bases. This is what we consider to be the perpendicular height. Okay? So actually, if I redrew that triangle, there's my perpendicular, and I did this. I have a 60-degree angle here. Perpendiculars are always 90, right? They always form a right angle with the side that they're forming the angle with, so it always creates a 90. The hypotenuse is 25, and this is the side we're looking for. I need to know what that value is. Okay? Let's label what we know. Across from a 30-degree angle is n. The hypotenuse is always 2n. And then the third side is going to be equal to n square roots of 3. So I have to figure out which one of those three am I able to solve. So if you look at the short side, it's just n. Can't solve that. If I look at the long leg, I have x equals n square roots of 3. And since I do not know what n is equal to, I can't solve that. But if you look at the hypotenuse, 2n equals 25. I could solve that equation. So I'm going to rewrite that over here. 2n equals 25. And I'm going to divide both sides by 2 to isolate my variable. Okay, so I'm going to get 12.5 for n. And the question's asking me to find the perpendicular height. So I need to find what x is. And if I know n, I'm going to plug it in. So x equals 12.5 square roots of 3. You could actually calculate that out if you wanted to. So do 12.5 times the square root of 3 on your calculator. And you find out that the long leg is approximately 21.7. So x, or the long leg, is 21.7. That's what you are looking for. Okay? So special right triangles. They're asking us to take the sides, label them with whatever the pattern is, fill in what you know to be true for lengths, search for the one that's in equation, and then solve that equation. Once you know what n is, you can plug it into all three sides to find the answer. Okay? So maybe take those steps and write them down, the ones that I just said to you, and follow them throughout the problems. So I'm going to stop the video here, and I'm going to do a second video for the word problems on the second page of your notes for section 8.2, the special right triangle section.